How did this one go? How did number 4 go? Adam?
Yeah, I was going to ask.
Yeah, let's try number 4. Let's talk about number 4. An angle terminates in the given quadrant with the value of one of the trig ratios. Find the other 5 trig ratios and the angle. Okay. So at the end of the class, I said you could use either approach, right? You could use drawing a triangle approach, or you could use the knowledge that x squared plus y squared equals r squared, because one side of the triangle plus the other side is going to be equal to the hypotenuse, right? So let's take this one, Adam. They gave you sine of theta equals root 6 over 3. Agreed? Okay, so what information is that giving us? That's giving us a lot of info, right? Yeah, hopefully you're thinking this, that sine of any angle is equal to y over r, right? Y over, or opposite over hypotenuse, y over the radius. Okay, so then that tells me that y is equal to 6 and r is equal to 3. So I'm just going to use my Pythagoras statement, x squared plus y squared equals r squared. Because in order to find all 6 ratios, this is what I need. I need to find, I need to find cos of the angle, which is x over r. I need to find tan of the angle, which is y over x, right? And then I need to find their reciprocals, which is just flipping them all, right? So basically, I have y and r. If I'm given a ratio, I have 2 out of the 3 pieces. I just need to find x. Okay, so x squared plus root 6 squared equals 3 squared. X squared plus 6 equals 9. X squared equals 3, so x equals root 3, right? Then I have all my 3 ratios. So then cos of the angle equals root 3 over 3. Tan of the angle equals root 6 over root 3, or root 2, right? It says find the angle 2. Okay. And then my reciprocals are going to be cosecant equals the flip of sine, so 3 over root 6. Secant is the flip of cos, 3 over root 3, and I don't have to rationalize. And cotan equals, I guess, 1 over root 2. Okay. Now it also says find the angle, and it says this is in the first quadrant. I told you what quadrant it's in. So find the angle. All right. So I think I'll use I'm going to use sine theta equals root 6 over 3 to find the angle. So the angle equals, so this will be my reference angle, right? But it'll also be my answer too, right? What'd you get, Adam?
54.74.
Okay, it said shift sign. Oh, I have to go back to, now that's interesting. It didn't tell me to solve in degrees or radians, right? So I'm in radian measure, so I could do root 6 divided by 3. So the angle equals 0.9553, or I can switch to degrees, which is probably what most of you did. Shift sign root 6 divided by 3, 54.74 degrees. Okay, because it didn't say degrees or radians. Right? And then B is the same thing, except just with different, they gave you x and r this time if they gave you cos, right? All right, I'm going to actually, because I'm not sure, we didn't get to this part, there are 2 more questions in our examples booklet like this, and if you didn't get this done for homework, it'd be more good practice for you. But I want to reinforce a little bit about what these reference angles are and why how reference angles tie into what we're doing here. Notice here we were finding, you had two parts to this question, right? It said find all trig ratios. And then this one was solve for theta, right? Solve for theta, which basically find the angle measure associated with the trig measures, with the trig ratios. All right, so you found a complete set of ratios. That's what you did here. And then we found the angle associated with those trig ratios. The interesting thing is they told you the angle was in quadrant 1, right? I think that's what the instructions said. It said the angle falls in the first quadrant, okay? Because what they're saying to you is they're telling you exactly where the angle was, because the interesting thing is that sine of theta equals root 6 on 3, etc., etc. Cos of theta equals root 3 on 3, and tan of theta equals root 6 on 3, okay? Or actually, I shouldn't, hang on, I'm going to erase these, sorry. Sine of theta equals root 6 on 3, right? Sine of theta equals root 6 on 3 here. There's also another place in the quadrant system where sine of theta has the same value, equals root 6 on 3. My angle could have been in quadrant 1 and quadrant 2. Okay, and that's where reference angles come into it. So that's why they had to, we're looking for the angle in quadrant 1, because the answer could have been found in quadrant 2 first. I'm just going to stop there for a sec, because I'm going to show you why that's true and why reference angles are important. So let's just put a pin in this, and I'm going to just quickly show you, and I'm videoing this, so you can either take notes or just watch. So I'm just going to tell you why reference angles are important to solve for angles, right? So to solve for trig equations. So let's just look at this here for a sec. If I say that we have a reference angle, I'm going to give you a reference angle of 30 degrees, okay? So that's an easy one. I think you can do that in your head, right? So my reference angle of 30 degrees ends in quadrant 1, right? My quadrant 1, quadrant 2, quadrant 3, quadrant 4. What would the related angle in quadrant 2 be for a 30-degree angle? Thank you. So this whole angle measure is 150, right? And the reason it's 150 is because it's 30 degrees away from the x-axis, right? So my reference angle is 30 degrees, okay? What's the quadrant 3 angle associated with 30-degree reference angle? 210, right?
Yeah.
So this is 210, and it's 210 because it also is 30 degrees away from the x-axis. That's what a reference angle is. And the last angle with this group, with this family, 330, okay? Now, there's two things to take away from here. They all have the same reference angle, and that's really important. We say they're all related because you know why they're related? I'm going to show you something. They all share the same values for the 6 trig ratios. They all have the same values. I'm going to show you something. If I, actually, Joanna, can you punch in your calculator and tell me what sine of 30 is? Rahel, can you tell me what sine of 150 is? D, can you tell me sine of 210? And John, sine of 330. Joanna, sine of 30 degrees? 0.5. Eileen, did you find 150? No. Rahel? 0.5. D? Negative 0.5. And last, John, did you do this one? Negative 0.5. See what the family of related angles have? They all have the same values for trig. They all have a value of 0.5. The only difference is these two guys have negative signs. You know why they have negative signs? Well, let's think about it. It's our cast rule, right? Where is sign positive? Sign's positive here, sign's positive here. So what we're saying is, I can't draw a triangle. I can't draw a triangle with an angle of 210 degrees, right? So when you were given that, like for example, when we were given this point, -4, -5, and we said find all the trig ratios, -4, -5, and solve for the angle, I can't, if I tried to find that point where -4, -5 was, okay? Well, here's the terminal arm. The angle itself is this angle, right? I can't draw a triangle. I can't draw a triangle with that angle measure, right? I can draw a triangle with this angle, this little reference angle. So what I do is I find all the trig ratios associated with this angle, and I find this angle measure. But you know what? I find the angle measure associated with the reference angle, and then I just do my 180 plus the reference angle to find the real original angle. Do you know what I mean? I'm just using the knowledge of the reference angle. So if they told me to find the sine, cos, and tan of this angle, there's no way I can do it. I can't do it. Because there are our sine, cos, and tan ratios. You know how you learned them way back in grade 8 or 9? They haven't changed, but they only come from an angle with all angles less than 90 degrees, right? It's a 90-degree triangle. If it's a 90-degree triangle, both these angles have to be less than 90. Like, they have to add up to 90. So there are no trig ratios for these types of angles. So what we do is we say, okay, well, I'm not going to solve for the big angle. I'm just going to solve for its buddy, the reference angle, right? I find all the trig ratios associated for its little reference angle. Then I say to myself, okay, well, the sine, cos, and tans will all be the same. All I have to do is play with the signs if they're positive or negative, right? And then I solve for my cast rule. Make sense? Kind of? Yeah? So what about this one? If I said to you, how about this? Find, well, actually, you know what? Let's go to your booklet. Let's make it a little more, because we've got holes in our booklet. On page 13, we didn't do these two examples, so treat them like homework. For each trig ratio, determine the 5 other trig ratios for theta in the given domain and solve for the angle. Okay? So this is kind of interesting. So let's look at this closely. This time, I didn't give you a point, right? I actually gave you a ratio. So you have one of the ratios given to you. And by the way, I didn't even give you the quadrant. So this is going to be an interesting one. So let's think about this. What do you know about this trig ratio? There's lots of things I hope you know. Sine theta equals 2/9. What info does that tell you? It tells me what, Joanna? Op and hypotenuse. And when we're talking in terms of the circle on the unit circle, in standard position, we'd probably say y/r, right? That's the first thing you should notice. When you're given a ratio, you're given 2 of the values, right? When you're given a point, when we were given these guys, you're also given 2 of the values, right? You're given x and y. Here, you're given x and y. And you just had to find r. When you're given a ratio, you could be given x and y, but this time you were given y and r. So then you have to find x, right? Because you're told that this angle is, it lies on the terminal arm of a point in standard position. So we know this is my sine of theta equals y over r equals 2 over 9. So that means y equals 2, r equals 9. Agreed? So find x for me. Oops. Already. Okay.
77.
Oh, thank you. And we're just leaving it in radical form, right? You don't have to do any simplifying. Thanks, Adam. Square root 77. Okay, that's the hard part. That's probably the hardest part for this part 1. All right, determine the 5 other trig ratios for this angle. What are the 5 other trig ratios? Just name them for me. Cos, tan, cosecant, secant, and cotan. Okay, you have all the info. Kinda. So what does cos equal to? Root 77 over 9. The only thing is, this time, have you noticed that they didn't tell me what quadrant it was in? Agreed? All they told me was that sine is positive. So all we know is that sine theta has a positive value. What's that? Okay. So if sine is positive, where does the terminal arm of this angle fall? Like, what are the possibilities? So this angle ends in quadrant. Well, where is sine positive? 1 or 2, right? They're not really, they're being vague on us, or forgot to tell us where it's lying. So I have to answer that, well, this angle could be, this trig ratio, if it's positive, the angle itself could terminate in quadrant 1 or 2. That means cos could be positive or negative root 77 over 9. Because cos is positive in quadrant 1 and negative in quadrant 2. Same with tan, right? Root 77 over 9, or sorry, positive or negative. Tan is y over x. So we've got 2 over root 77. And now these are just the reciprocals, right? So this cosecant is just the flip of sine, so it'll be 9 over 2. And cosecant's the only one we know that's positive for sure, because it's the reciprocal of sine. If sine's positive, so is cosecant. Secant could be positive or negative. 9 over root 77. And cotan is root 77 over 2, and it could be positive or negative. Because they didn't tell me what quadrant. Right? Okay, and what about the angle measure? Again, because I don't know where this trig ratio, what angle they're referring to, it could be either in quadrant 1 or quadrant 2. So I want you to find the angle measures associated, and this is even trickier. It says from negative 2 pi to positive 2 pi. So that means we have to do a positive and a negative rotation. So let's do the positive notation or rotation first. Once around the circle, I want you to find me the angle associated with quadrant 1, and then the angle in quadrant 2. And this is degree or radian measure, right? And let's do 3 decimals. Okay, what's the reference angle you got? Anyone get a reference angle? 0.224. I agree with that. So that's your quadrant 1 angle, right? So that's one of your answers. You got one of your answers right here. What about your quadrant 2 angle? How do you find quadrant 2? Pi minus the reference angle, right? Okay, so I am lucky I can store my answer like I showed you before. So I can just go pi minus my reference angle. Whoops. And I get 2.917. Agree? Okay, so here's my 2 answers in the positive direction. What about in the negative direction? Let's just do this once because we haven't seen one like this before. Now if we went around the unit circle in a negative direction, okay, so I move around, this is 0, this is negative pi, right? And then all the way home is negative 2 pi. Sign is still and always will be positive in these 2 quadrants, quadrant 1 and 2. Okay? I still call them just quadrant 1 and 2. I guess you could think of them as negative 3, negative 4. So I need to find the angle associated, the reference angle in this quadrant, right? Moving backwards. So when I'm moving backwards, this angle measure has to be between negative pi and negative 2 pi. So see if you can figure out what the reference angle is, or sorry, what the answer is in quadrant 2 and quadrant 1, positive 2, positive 1. You're getting more and more negative, right? And then you can tell me the process you used, how you found it. Okay, so once again, it should be a number between, like, both of these numbers have to be numbers between negative 3.14 and negative 6.28, right? So who got an answer for this quadrant? Anyone want to be brave? No? All right, I got negative 3.366. Anyone agree? So what I did is, this is my starting point, negative pi. Okay, I'm going this way around the unit circle, right? So I'm getting more and more negative. I just did negative pi minus my reference angle. Okay, the reason I did minus is I'm going in the negative direction, right? Okay, and that gave me this as an answer, negative 3.366. And then this way, for this reference angle, I'm starting at negative 2 pi, and I'm moving backwards, right? Because the reference angle is coming off the x-axis in the opposite way, so it's in the positive direction. And I got negative 6.059. As answers. Okay? Yeah.
How do you set up the negative part?
Okay. How do I set up my negative circle? Okay, so if I think about it, going in the negative direction, this is always your 0, right? So if I go here, this will be in the negative direction. This is negative pi on 2. This is negative pi, negative 3 pi on 2, negative 2 pi. Okay? So if I'm finding reference angles, or sorry, if I'm using a reference angle from here, from this quadrant to this quadrant, it's going to be negative pi. I'll do it in red. Okay. So negative pi, and I'm going in the negative direction, right, John? So negative pi minus my reference angle equals whatever angle I'm looking for. Here, start negative 2 pi, and I'm going in the positive direction. Here, if I'm finding an angle down here, it's going to be negative pi, and I'm going in the positive direction. And here, it'll just be 0 minus reference angle. Okay? Yeah? Okay, try this last one for me, and then I'm going to give you a worksheet. Sorry? Yeah? I can scan it and put it in the blog too. Look, I want you to try this one for me, but you know what? I'm going to change the search area, okay? I'm just going to make it easy. Let's just do from 0 to 360, okay? Because I want you to try this one on your own. All you know is that tan theta has this value, negative 12 over 7. I want you to find the 5 other ratios, and I want you to find the angle, and it says the possible values for the angle. So the possible values for tan associated with a negative ratio. So where does tan have a negative ratio? Where is tan negative? 2 and 4, right?
Yeah.
So the trig ratios will be the same in 2 and 4. So just give me the trig ratios, but you'll have to do the trig ratios for, all you know is that tan is negative. So that means cos and sine could be either positive or negative, but you're going to come up with 2 different angle measures for that, right? Because you'll have an angle measure that terminates in quadrant 2 or an angle that terminates in quadrant 4. Okay, did everyone get our value of root 193?
Yeah.
Okay. So then after that, that's the toughest part, right? You just have to remember, okay, cotan's easiest. If you've got tan, you just have to flip this around and it's cotan, right? I knew cotan was negative. The others, because I don't know what angle it could possibly terminate in two quadrants. So they could be positive or negative, but sine has, the value is 12 over root 193, right? Yeah? Okay. Cosecant is the flip of that, root 193 over 12. Secant is root 193 over 7, and cos is the flip of that, right? Now, I don't have enough room to do my angles, but what quadrant, you are limited to quadrant, it's either quadrant 2 or quadrant 4, agreed, that this angle terminates in? Because they told me that tan was negative, right? So I do know that. I don't have to answer all 4 quadrants. So my quadrant 2 angle, well, first what I do is you always have to find the reference angle first, right? And finding the reference angle, it's going to be shift tan 12 divided by 7, right? Agreed? Finding reference angles, they're always going to be positive, so I don't enter any negatives in. And now the other thing is, because you were told to solve in degrees, you're going to have to go back to your calculator, right? And make sure you're in degree mode. Your calculator is usually easier to do than a graphing calculator, right? And if you don't know how to do that, tell me, and I'll figure it out for you. So 12 divides 7, I'm always going to get a positive angle measure acute, less than 90 degrees or less than pi on 2. So this means my angle is equal to 59.74 degrees. Okay, that's my reference angle. But that's not my answer. I have answers in quadrant 2 and quadrant 4. So in quadrant 2, it's going to be 180 minus my reference angle, which is going to be 120.26 degrees. And then in quadrant 4, it's 360 minus my reference angle. Oh, thank you. I ended up getting 0.26. Yeah. John, if you do it? Yeah. Okay. So those are my 2 answers. Okay? Lots of work for these, right? It's because those are repetitive values. Okay, I just want to, I want to hammer this home. I want to do one more thing with you, and then I got to give you a worksheet to work on. Not for marks, but for feedback, okay? So if you flip the page over, page 14, we're going to do one of these and one of these, and then I'm going to get you to do the second one on your own on the weekend. To the nearest hundredth of a radian, determine possible values for theta in the domain 0 to 2 pi, so just once around the unit circle. If it gives you cos of theta equals 0.85, okay? This is exactly what we were just doing, if you think about it. This is the second part of this, right? You were given a tan of theta equals a ratio, find theta. Sine of theta equals a ratio, find theta. But the 2/9, for example, here, when I do my division, it's just it ends up just being a decimal number anyway, right? The 12 divided by 7 here, it's just a decimal number. So you're doing the same thing, kind of with some of the preliminary steps taken out. I guess they've already done their ratio division, right? So when I look at a question like this is a very simple trig equation, right? A trigonometric equation is when you're being asked to solve for an angle, solve for theta. And you're being asked to solve for theta here, so it's a trig equation. So once again, and this is probably similar to how your grade 11 teacher started you off with these, I say to myself, cos has a positive value. So where is cos positive? Right? Did they do something like that for you? And then you found a reference angle and you applied your reference angle knowledge in those two quadrants. You just have to pay attention because you're in grade 12 now. You're solving trig ratios in radians and degrees. Back in grade 11, you were just doing degrees. So part of your job now is to look at what they give you for instructions and say, okay, this is radian measure. So I'm going to use this guy. He's easier. For these, somewhere in your calculator, you probably have something that says DRG. That's usually how you flip back and forth. So I just keep pressing till I see radians. Okay. So I'm going to go second cos 0.85, and I get a radian measure of 0.55, I guess, to the 100th, so we're just using 2 decimals. Okay? Now this is the important part. Even though that was what they asked me for or actually that isn't what they asked me for, is it? This isn't my answer, so I'm actually going to record this. This is what you guys are going to have to do, unless you have a storage feature on your calculator, okay? So you're going to have to record all the digits before you actually answer the question, or find your storage feature. So in quadrant 1, I've got a quadrant 1 angle and a quadrant 4 angle answer. In quadrant 1, it's going to be equal to 0.55. In quadrant 4, how do I find my quadrant 4? 2 pi minus my reference angle, right? So I'm going to go 2 pi minus 0.554811033. I know that's a bit of overkill, but I want to make sure I don't get a rounding error. 5.73, right? So this one was easier. Solving trig equations is easier than finding all the trig ratios, right? That last example we did, we found all the trig ratios and we solved for theta. Here we're just solving for theta. Okay, so you can do this one at home. Let's try in degrees. Let's try 1 in degrees, because here we're doing degree measure. Okay. So which one do you want to do, A or B? Pick one. A? Okay, let's do A. All right, where am I looking? What quadrants am I looking in? What quadrants will my angle terminate in? It's got to be here and here, right? Okay. Find your reference angle. This one says to the nearest degree, but when we're finding a reference angle, we don't round here, right? Keep at least 5 digits, I would say. I mean, I went a little crazy here. I used 1, 2, 3, 4, 5, 6, 7, 9. Probably don't need 9 to get a right answer, but you need at least 5. If you go less than 5, there's a possibility you get a rounding error. Okay, who's going to be brave for me today? No brave souls. Quadrant 3 answer?
180 plus.
Mm-hmm. So what'd you get for your final answer there, Eduardo? Did you get it yet? So I get, if they're saying round to the nearest degree, what would it be, Eileen? 214. Yeah, 214? Okay. What about quadrant 4? .25, right? So that would just be 326, right, Ibby? Perfect. Okay. Good. But what does it say in your domain? It says from negative 360 to positive 360. So we did the positive rotation, right? We did positive answers or positive rotations. Okay, so now let's do negative rotation. Degrees are always easier to work in. They're whole numbers, you have lots of familiarity with them. Okay, so what would your negative rotation look like? So here was positive, right? 0 to 360. Here we're going negative, right? So everything's negative angle measures. We still start at 0, but instead of 0 being on the top, 0 is on the bottom, right? So we go all the way around. And we have negative 360. Now, when I'm solving for a trig equation, the only axis you need is your x-axis. Don't label your y-axis if you're solving for theta, because you're not using it. I think that'll just confuse you. You should just be thinking of your x-axis, because it's just your x-axis that you use for your reference angles, right? It's still here and here, quadrant 3 and 4. I always just refer to them as, even though we're measuring negative, but it's quadrant 3 and 4, or it's negative quadrant 1, quadrant 2, however you want to say it, but okay, it's here and here. Actually, I should do this right. Sorry, Ibby, I'm way behind you. So here, what did you say?
I got 34.
I think it's just going to be 34, right? Because it's just going to be 0. So I'm moving here, right? I'm moving in the negative direction, right? So it's just like, you know that little picture you just looked at? Here. Right? It's the same thing. It's 0, subtract your reference angle, right? So it'll be, gives you your angle. So it's going to be, oh, sorry, thank you, negative 34 degrees. And then here, what did we say here? We're starting at negative 180, right? And we're going in the positive direction, right? So it's negative 180, moving in the positive direction, plus your reference angle, and that equals, thank you, negative 180 plus,
Would you be able to just like find the coterminals of the arms themselves? Just minus 360 from 214 and 326?
yeah. So I get this time what, a negative 146? Like when you say the coterminals, you mean the related angles, right?
Yeah. I take the actual positive angles that we got and just take 360 away from it.
And just keep it to the only the quadrants you need, right? So it's not so bad if you're given negative rotations, but if you're given negative rotations and positive, you have to do them separately, right? Because they're different processes, I guess. Okay, so that's solving for trig equations, which is all you were doing here, except you were also doing all that extra stuff about finding all the trig ratios too. Okay. All right, I'll post all these notes on the blog too.